Hey, this is Mr. Ward, and I'm going to talk to you a little bit about one of the three major tools we're going to work with for solving a system of equations. And this tool is called substitution. And in substitution, what you're going to want to do is you're going to solve for a variable. You're going to isolate a variable in one of the equations you've got so that you have an expression you can substitute for it in another equation in the system. I've come up with a little word problem here in order to illustrate this. So you're having a race with your little brother. Because you're being nice, you give your little brother a 45-meter head start. You want to figure out how long the race would have to be for you to catch up with your little brother. He runs 3 meters per second and you run 5 meters per second. Now, there's lots of mental math tricks for solving this one, but I'm going to use substitution. So I'm going to start off by coming up with equations for you and your little brother in the race. So your little brother has a starting place of 45 meters and a rate of 3 meters per second. So we should use a slope-intercept form. So y equals slope of 3, because it's the rate, times x, plus your little brother's starting place. You can see it's graphed over here. So graphing could solve this as well. Now you run 5 meters per second, but you are not getting a 45-meter head start. So your equation would simply be y equals 5x. The y-intercept would be 0, and we don't really care about that, so we're just going to leave it like that. And so what we want to know is when are you in the same place? So you're trying to figure out how long will be x will be time, okay? How long it will take before you catch up with your little brother. Catching up will be y, or should I say how far you've gone will be y. So what you wanted for catching up, y needs to be the same. Now in this case, you already have a variable isolated. So we need to know what x would be when y is the same. So if y is the same and y equals this and y equals that, then we could actually say this equals this. So what we can do is we can copy this equation, okay, and y equals 5x, but y also equals 3x plus 45. And when y is the same, we can just replace y with 3. We can substitute for y with 3x plus 45. And now we have an equation we can work with because it only has one variable. So one variable means you can solve for the variable. So let's solve for that variable. So we want to get the variables on one side. Probably the easiest thing to do is subtract 3x from both sides. So I'll say 3x minus 3x on this side and 5x minus 3x. I'll simplify that, and that's going to end up 3x plus minus 3x over here goes away, since up with just 45 over there. And 5x minus 3x is going to end up being 2x. And now I just divide both sides by 2. 45 divided by 2 equals 2x divided by 2. And 45 divided by 2 is going to be 22.5. And the 2's cancel out. So x is 22.5. Now, we know how many seconds it'll take before you catch up. Let's figure out also how far you will have each gone. So now that you know what x will be when you're in the same place, let's replace x in these equations with 22.5. So I'll say y equals, I can use this as the easy one to work with, y equals 5 times 22.5. And so you will have gone 112.5 meters. And I can test it out with the other one. You'll have gone 112.5 meters after 22.5 seconds. I can do the same thing with this. Y equals 3 times 22.5 plus 45, and we get the same answer. So y is 112.25. And so we have a solution for this system of equations at x is 22.5 and y is 112.5. So after 22.5 seconds, you will have each gone 112.5 meters. So if you want your brother to just barely beat you and feel proud of themselves, make the race around 20 seconds. If you want to beat your brother just by a little bit, make the race 24 or 25 seconds, assuming everyone goes the same speed. I'm going to shrinky dink this over here and let's take a look at our graph. I'm going to actually make this disappear and this disappear. And these stop graphing because they're all just graphing that vertical line. What I want to see is the intersection point. So here we go. There's our intersection point at 22.5, 112.5. Now, you could have graphed this to solve it. You would have ended up having to eyeball a halvesies kind of point because it's right there in the middle, not actually on one of the grids. So it's on a half grid once we zoom into here. But this would be harder to solve by graphing. All right, I'm going to take another example for solving a system of equations using substitution. Let me turn those graphs off so they're not distracting. Move this over here, and I'm just going to create a couple of equations. Now this time, it's not going to be as simple as y equals an expression, y equals another expression. So here we go. We're going to have 2x plus y equals 9 and 3x minus 4y equals 22. So this will be a little more complicated. So what I'm going to be doing is I'm going to be sniffing around these two equations to see, is there an easy variable to isolate? 3x and 4y and 2x are all going to be a little more complicated to isolate. Y all by itself with a coefficient of 1 should not be terribly hard to isolate. So I'm going to work with that one. So to isolate that, I'll subtract 2x from both sides. So it'll be y will equal 9 minus 2x. That's the same thing. And actually, I'll show you the step. 2x minus 2x plus y equals 9 minus 2x. And then, of course, the 2x minus 2x goes away. This cancels out. And I'm left with y equals 9 minus 2x. Once I have y equals 9 minus 2x, I'm going to go to the other equation in the system, not the first one. If I just plug this in to my first equation, I end up with just 0 equals 0. That won't help me. I want to plug it into this equation. So I am substituting in the other equation. I now have an expression for y in terms of x. So this y, I am going to substitute this expression for y. So y is now going to become, let me now do this. I want to show you in a stack. Y is going to become 9 minus 2x because that's what it is in this system of equations. That's what it will be for the solution. So now I have an expression that's kind of annoying. And now you might start to see one of the reasons way back in equations I gave you some annoying equations to solve. I'm going to now solve for x. It's one variable. I can go through the process of solving for x. So first thing to do, I'll go ahead and distribute the 4. So negative 4 times 9 will be negative 36. So minus 36, and negative 4 times negative 2, so it's negative 4 times negative 2x will end up being plus 8x. And now I can combine like terms. 3x plus 8x is 11x. I've still got minus 36 equals 22. I now can add 36 to both sides. So plus 36 here, plus 36 here. The 36 minus 36 plus 36 goes away. And the 22 plus 36 becomes 58. And now I just divide both sides by 11. So that by 11 and this by 11. And 11 over 11 will cancel out. So I'll just have x equals 58 over 11. All right, at this point, I have choices. I have 58 over 11. I can go back to one of my original equations and figure out what y is with 58 over 11. So I can use one of my original two equations, these two here, 2x plus 9 equals 2x plus y equals 9, and 3x minus 4y equals 22. I could also use the one where I've already isolated y, and that's actually what I'll probably do. Since I've already isolated y, I just need to work out what 9 minus 2 times 58 elevenths is. So let me copy that. It'll work for any one of them, but that's probably going to be the easiest one. And I like to find the easy thing to do. So what I'm going to do is I'm going to identify y there, or identify x. And since I know x has to be 58 over 11, I'm going to substitute 58 over 11 for x. And now I just have to work out what this is. 2 times 58. Let's work it out. So 2 times 58, that's 2 times 58 over 11. 2 is a numerator, so I'm going to do 2 times 58. 2 times 58 will be 116. Okay, and it continues to be negative. And I need to get a common denominator here. So 9 is the same as 99 over 11. And now I can work out what 99 minus 116 is. 99 minus 116 is going to be negative 17. So y is going to equal negative 17 over 11. And now I have a solution for my system. So I figured out what y is, and I figured out what x was. So I can put it all together, and I'm putting it all together down here. I've got a point at 58 over 11, comma, negative 17 over 11. Notice the denominators both ended up being the same. You'll see off here, it's giving me a repeating decimal thing. I wouldn't bother with that. I would just use the improper fractions that we just came up with for the solution. Now, these are really ugly numbers to work with, especially if you were graphing. So substitution ends up being a much better tool than graphing for this. Now, in the next part of systems, you'll learn about elimination, which is my favorite method. But you want to know all of the methods because there's going to be times when graphing, substitution, or elimination, any one of those is more useful to you. So our solution for this system is 58 over 11, comma, negative 17 elevenths. I'm going to zoom out onto the graphs, and you can see that solution right there. These horizontal and vertical lines are just what's happening when I'm solving for a single variable. Once I'd have eliminated one of the variables through substitution. But this line here is actually, it is both that, but it is also, let me turn that off. There we go. It is our original equation, 2x plus y equals 9. And this one here is our original equation, 3x minus 4y equals 22, and they do indeed intersect at what has been rounded, 58 over 11, negative 17 over 11. I've gone on for a little while, but this is an important topic, so I hope that's been helpful. In my next video, I'm just going to work some problems, and I'm going to ask you to pause and try them yourselves. I'm going to stop now.